friends, we will solve some numericals on moles, molecular weight, density on this. Okay, so for this what we should know? We should know the formula for atomic mass, what is Avogadro number, what is molecular weight. Okay. So first problem, find the moles of oxygen present in 500 grams. How to solve this? First, let us write what is the given data. It is given, the mass is given, that is weight or mass is given 500 grams. How to find the molecular weight? Molecular weight of oxygen, we know that one atom is 16, so it is oxygen molecule has a molecular weight of 32 grams per gram mole. To get moles, the formula moles by molecular weight. Moles is mass by molecular weight. So mass is given 500 grams, molecular weight of oxygen is, oxygen molecule is 32 grams per gram mole. So the gram get cancelled and in the numerator we have gram mole. So 500 by 32 is 15.625 gram moles. So that is the answer. So it was asked, find the moles of oxygen present in 500 grams. So weight is written 500 grams, molecular weight of oxygen is 32. So mass by molecular weight gives us the answer, that is 500 by 32, which is 15.625 gram moles. That is our required answer. Next problem is, find the molecular weight of potassium permanganate, KMnO4. So how to solve this? We have to find the molecular weight of potassium permanganate. So first we will write the number of elements N, and we will write the atomic mass, then we will make the product of number of elements into atomic mass. So we have one potassium atom, one manganese atom and 4 oxygen atoms. So 1 into, and we are writing the atomic mass 39 for potassium, 54.93 for manganese, oxygen 16. So we have 1 into 39, 39, 1 into 54.993, 54.93, 4 into 16, 16. So the summation of N into Ma is 157.93, which is our required molecular weight. So the molecular weight of potassium permanganate is 157.93 grams per gram moles. 157.93 grams per gram mole. So that is our required answer. That's our required answer. So we have to find the molecular weight of potassium permanganate. We have written the number of elements 1K, 1Mn, 4 oxygen. So their values are 39, 54.93, 16. So there is a correction, 16 into 4 is 64. So the total molecular weight you will get is 157.93, which is our required answer. Come on, let us do another problem. How many grams of ammonium chloride? How many grams of ammonium chloride are there in 5 moles? Ammonium chloride are there in 5 moles. Solution. So first let us write the given data. So it is given that there are 5 gram moles of ammonium chloride is there. 5 gram moles of ammonium chloride is there. So first we have to determine the molecular weight of ammonium chloride. Molecular weight of ammonium chloride, NH4Cl. So there are N, H and Cl. So how many number of elements are there? Number of elements of, so number of moles, number of elements. So number of elements N are 1, there is 1 N nitrogen, so there is 1 hydrogen, so N equal to 1 for nitrogen, N equal to 4 for hydrogen, and there is 1 Cl. And what are the atomic mass? So atomic mass are, for nitrogen we know 14, for hydrogen 1, for chlorine it is 35.5. So now what we have to do? We have to multiply this N into atomic mass Ma. So N into Ma we have to first determine. So calculate this. Yeah, yourself you do the calculation. What is 1 into 4? 14. It is 14. 4 into 1 it is 4. So 1 into 35.5 it is 35.5. So the summation is, what you will get, 53.5. The summation of 14 plus 4 plus 35.5 is 53.5 grams per gram mole. So the molecular weight of ammonium chloride is, molecular weight of NH4Cl is equal to 53.5 grams per gram mole. Now it is easy step for us. What we have to do? We have to just find the mass. How to find? So when you multiply number of moles by molecular weight, when we multiply number of moles by molecular weight, we will get the mass. So what is the number of moles given? In given data we have, it is 5 gram moles. 5 gram moles. So we will write gram moles. We know that moles or gram moles represent the same. Okay, 5 gram moles multiplied by molecular weight, which is 53.5 gram per gram mole. So we have these 5 gram moles. This gram mole will get cancelled. So we will get grams as the answer. So that is the question. How many grams of ammonium chloride are there in 5 moles? So we have written the given data, 5 gram moles. So number of elements we have written down first. 1 nitrogen, 4 hydrogen and 1 chlorine atoms. So the atomic masses we have written. Okay. So once we have written this atomic mass, there is 1 chlorine atom. So atomic masses are, for nitrogen it is 14, for hydrogen 1, for chlorine it is 35.5. So when you make the product, 1 into 14, 14, 4 into 1, 4, 1 into 35.5, 35.5. So we have 53.5 as the molecular weight of ammonium chloride in grams per gram mole. So to find the mass, we have multiplied this molecular weight with the number of moles. So gram mole getting cancelled, and we are getting 267.3 grams as the answer. Okay, so that is the required answer. So we will please write it down as, there will be 267.3 grams of ammonium chloride in 5 moles. So you can write it as sentence. Ready for next problem? Let us do one problem on copper sulfate, hydrated copper sulfate crystal. Convert 499 grams of copper sulfate 5H2O, CuSO4 5H2O into moles. Convert 499 grams of copper sulfate 5H2O into moles. Find equivalent moles of copper sulfate. Find equivalent moles of copper sulfate present in the crystal. Find equivalent moles of copper sulfate present in the crystal. So it is given 499 grams of copper sulfate, hydrated copper sulfate. How many equivalent moles of copper sulfate will be there? Before that, we have to convert this 499 grams into moles. Okay. So how to solve this problem? So first let us write the given data. Solution. It is given that mass equal to 499 grams. So first write that solution is given, mass is 499 grams. So what is the next step? Our first step will be to determining the molecular weight of, we will do it two stages. One is copper sulfate alone, then copper sulfate when it is hydrated with water. So both you will determine. So first determine the molecular weight of copper sulfate. So the crystal is copper sulfate with 5H2O. So first what we will do, we will write the for copper sulfate. First for copper sulfate what we have to do, first write the elements Cu, S, O. So these are the three elements present in copper sulfate alone. So the number of elements are 1 copper, 1 sulfur and 4 oxygen atoms. And the atomic mass we have to write. So we know that for copper it is 63.54, sulfur it is 32, oxygen it is 16. Okay. So what we will do, we will do N into Ma, then we will make a summation we get the molecular weight of copper sulfate alone. Then for molecular weight of the crystal, so we will add the molecular weight of copper sulfate plus 5 times the molecular weight of water. So if you write down the atomic masses, we get 63.54, 32, 16. 16 into 4 is 64. So we get molecular weight of copper sulfate as 159.54. So to get the copper sulfate of hydrated copper sulfate crystal, so we will add 5 times 18 to the molecular weight of copper sulfate, which is 159.54. When you make this summation, so we get the number of moles to be gram moles, 2 gram moles. Okay. So we have converted 499 grams into 2 gram moles. Now there won't be any change in moles because there will be only mass change. Therefore, because 1 mole of crystal contains 1 mole of copper sulfate. This one is a simple problem. How many potassium carbonates? How many moles of potassium carbonate will contain K2CO3 will contain 117 kg of potassium. 117 kg of potassium. How to solve this? First step is to determine the molecular weight of K2CO3. Okay, solution is first step. We will find the molecular weight of K2CO3. So then we will write the mole equivalence. 1 mole of K2CO3. How much moles of K? So then we will convert them to mass equivalence. Okay, so first we will do mole equivalent. Then we will write the mass equivalence. Then for the given mass of 117 kg of K, what is the equivalent K2CO3 we are going to find out. Okay, what is the equivalent K2CO3? For a given mass of K, what is the corresponding mass of K2CO3, and then finally what is the moles of K2CO3? That's what we are going to find. So for this we should know what is the atomic mass of K. So atomic mass of K is 39 kg per kg atom. So we will find out the molecular weight of K2CO3. Molecular weight of K2CO3. So we have write KCO in one row, then number of elements of KCO in the next column. So N. So N for K is 2. N for K is 2. Then we will write what is atomic mass. N for K is 2, C is 1, and oxygen it is number of atoms 3. So atomic mass of K is 39, carbon 12, oxygen 16. Then what we will do? We are going to multiply N into Ma. So 2 into 39, 78, 1 into 12, 12, 3 into 16, 48. So total is 138. So 138 kg per kg mole. So what you get? Molecular weight of K2CO3 is 138 kg per kilomole. Now we write the mole equivalent. How many kg atoms of K are there in K2CO3? 1 kg mole of K2CO3 contains 1 kg mole of K2CO3. 1 kg mole of K2CO3 contains 2 kg atom of potassium. Kg atom of potassium K. So what we will do? We are going to multiply by molecular weights on each side. So respective molecular mass or atomic mass. So left hand side we have to multiply by 138, right? So multiplying by molecular mass on both sides respectively. So 1 into 138 kg of K2CO3 contains 2 into 39 kg of K. 39 is, see, K is 39, what is K2? 39 into 2, that is 78 kg. Okay, kg per kilomole. So 2 into 39 kg of K. So what is that? The left hand side is 1 into 138, that is 138 kg of K2CO3. Right hand side, that is, it contains 138 kg of K2CO3 contains 78 kg of potassium K. So therefore, question is 117 kg of K. What will be, how many kg of K2CO3 will contain 117 kg of K? So it is given 117 kg. So right hand side value is given. So 117 kg. 138 kg of K2CO3 will contain 78 kg of K. So then how much kg of K2CO3 will contain 117 kg of K? So let us say if it is X kg of K2CO3 will contain 117 kg of K means what is X? Please determine X. X into 78 equal to 117 into 138. So X equal to 117 into 138 by 78, which is 207 kg. So we get 207 kg of K2CO3. 207 kg of K2CO3. So right. So we have to convert it into moles. Mass by molecular mass. We will get number of moles, which is 1.5 kg mole. We will get 1.5 kg moles. The next problem: how many grams of carbon is present? How many grams of carbon is present in 264 grams of carbon dioxide? How many grams of carbon is present in 264 grams of carbon dioxide? Solution: first let us write the given data. How many grams of carbon is present in 264 grams of CO2? Solution: first write the given data. Mass of carbon dioxide is given, that is 264 grams. So what do we have to do now? We know the reaction, right? So we know that C plus O2 gives CO2. There is a combustion reaction. Hold. When you supply air, C plus O2 will give CO2. So we will write the gram equivalence. 1 gram mole of carbon reacts with 1 gram mole of oxygen to form 1 gram mole of CO2. 1 gram mole of carbon reacts with 1 gram mole of oxygen to form 1 gram mole of CO2. Again, so as we did in previous problem, we have to multiply by molecular mass or atomic mass respectively. So carbon atomic mass is 12. So we get, multiplying by molecular mass or atomic mass respectively. So here 1 into 12, it is. So first find the molecular weight of CO2. So CO2, carbon 12, oxygen 32, O2 is 32. So CO2 is 32 plus 14, 12. How much? 32 plus 12, it is 44. So the molecular weight of CO2 is 44. Molecular weight of carbon dioxide is 44 kg per kilomole or gram per gram mole. Okay, here we will use it as gram per gram mole because we are writing in terms of gram mole. So 12 grams per gram atom multiplied by gram mole of carbon. We can simply write 12 grams of carbon, right? So 32 gram per gram atom, 32 gram per gram atom. No, it is not 12, it should be 32. 32, so this should be gram atom. Okay. 1 gram atom or gram mole, whatever it is. 32 gram per gram atom of oxygen into 1 gram mole of oxygen will form 44 gram per gram mole multiplied by 1 gram mole of CO2. Gram mole of CO2. So all the denominator term gets cancelled. So what we can write? So what we are concerned here is only carbon and carbon dioxide. So for time being we are leaving this oxygen. Okay. So right. So we have 12 grams of carbon in terms of mass equivalence. 12 grams of carbon will form 44 grams of CO2. 44 grams of carbon dioxide. 12 grams of carbon will form 44 grams of CO2 during combustion. So when you have, so question given is 264 grams of CO2. So how much grams of carbon it contains, right? So that way x gram of carbon contains 264 grams of CO2. So we can find out the x easily. So x into 44 is equal to 264 into 12. So therefore x is equal to 12 into 264 divided by 44, which is 72 grams. 72 grams. So question was how many grams of carbon is present in 264 grams of CO2. So 72 grams of carbon will be there in 264 grams of CO2. So you can write answer 72 grams of carbon is present in 264 grams of CO2. 72 grams of carbon is present in 264 grams of CO2. So that is the required answer. This is a simple problem. I hope you have no issues in understanding this. I am repeating. So we have written the combustion reaction C plus O2 giving CO2. So we first wrote the gram equivalence, then we wrote the mass equivalent. 12 grams of carbon will form 44 grams of CO2. So in question it was given 264 grams of CO2. So what is the corresponding grams of carbon? We have determined by x. Okay. So we have determined it to be 72 grams of carbon present in 264 grams of CO2. So we will do another similar problem. So in the previous problem, gram CO2 was given in grams, and what is the grams of carbon was asked. So in this problem, we will find out how many kg of CO2 will contain 3.5 kg mole of carbon. How many kg of CS2 will contain 3.5 kg of carbon? So first we will write the given data. So it is given 3.5 kg moles of carbon. Okay. So we know the reaction C plus 2S will give CS2. So 1 moles of carbon will form 1 mole of CS2. So in terms of kg mole, you can say 1 kilomole of carbon will form 1 kilomole of CS2. So it is given 3.5 kilomole of carbon. So it is direct substitution. It is given 3.5 kilomole of carbon. So it will contain 3.5 kilo. It will form 3.5 kilomole of CS2. Right? So this is equivalent. So if it is 3.5 kilomole of CS2, it's not CO2. It is CS2. So first we will find the molecular weight of CS2. Carbon 12, sulfur 32. So CS2 is 2 into 32 plus 12. So how much? It is 76. 64 plus 12, 76. So when you multiply by the molecular weight of CS2, kg per kg mole of CS2, it is CS2. So kg mole gets cancelled. So what we get is kg of CS2. So 3.5 into 76, how much? You will get more than 260. How much exactly? 266 kg. Yes, you will get 266 kg. So you can write in sentence. So what was asked? How many kg of CS2 will contain 3.5 kg moles of carbon? So we have written the reaction and gram equivalence, mole equivalent. 1 kg mole of carbon will form 1 kg mole of CS2. So that we can say 3.5 kilomole of carbon will form 3.5 kilomole of CS2. So that way we first determine the molecular weight to be 76. So when we substitute multiply by molecular weight, we get the final answer 266 kg. So now you can write it in sentence. As I always advise, please write it in sentence. 266 kg of CS2 will contain 3.5 kilomole of carbon. Will contain 3.5 kilomole of carbon. So that is the required answer. In the next problem, we are going to make use of Avogadro number. So take down the question. How many barium atoms are present? How many barium atoms are present in 416.6 grams of barium chloride? 416.6 grams of barium chloride, BaCl2. Okay, so how to solve this problem? Write the solution. First write the given data. The mass of barium chloride is given. Mass of barium chloride is given in grams. How much grams? So mass is equal to 416.6 grams of barium chloride. So this is the given data. So what we will do is usual. First we will find out the molecular weight of barium chloride. So we know the atomic mass of barium as 137.3, chlorine 35.5. So first write the number of elements, then atomic mass Ma. So N Ma, N and then Ma, N into Ma we will determine, right? So first write the name of the elements in the left hand side. So Ba and Cl, simple. So how many elements are there? 1 and 2 chlorine atoms are there. So 137.3, 35.5. So 1 into 137.3 is 137.3. 2 into 35.5, that is 71. So we get summation of this gives us the required molecular weight of barium chloride. So it is 208.3 gram per gram mole. You can write as molecular weight of barium chloride is equal to 208.3 grams per gram mole. How we get the number of moles of barium chloride? So dividing by molecular mass. Mass is given 416.6 grams. Divide by the molecular mass determined 208.3. We are going to get the number of moles of barium chloride. That is given, mass is given. How much it is given? 416.6 grams. 416.6 grams. Molecular mass is 208.3 grams per gram moles. So grams will get cancelled. In the numerator we have gram moles. So answer we will get is will be in gram moles. We get 2 gram moles. Please cross check the calculations always. In all the problems you have to do your own calculation. So we know that 1 gram mole of barium chloride contains 1 gram mole of barium chloride contains 1 gram atom of barium. 1 gram mole of barium chloride contains 1 gram mole of barium. So here what we have determined is 2 gram moles. Therefore 2 gram mole of barium chloride will contain. So we don't need to do anything like multiplying by molecular mass here, because here data is given in gram moles directly. If we are getting it in kg only, we have to multiply by molecular mass. So we need not do that. So please write. So 1 gram mole of barium chloride contains 1 gram mole of barium. Therefore 2 gram mole of barium chloride contains 2 gram mole of barium chloride contains 2 gram mole of barium. Okay, so now what we have is 2 gram mole of barium. So recall what is Avogadro number values. So what is the definition of gram mole? So 1 gram mole of barium will contain Avogadro number of atoms, that is 6.022 into 10 power 23 atoms. So what we have is 2 gram mole of barium. Therefore 2 gram mole of barium will contain 2 into 6.022 into 10 power 23. So the value is 1.2046 into 10 power 24 atoms. So 2 gram mole of barium will contain 1.2046 into 10 power 24 atoms. So that is the required answer. So what was the question here? How many barium atoms are present in 416.6 grams of barium chloride? So mass was given, so we have written the mass. So we have determined the molecular weight BaCl2. So there is 1 Ba, 2 Cl. So we determined the molecular weight and it came out to be 208.3. And once we got the molecular weight of the barium chloride, so mass divided by molecular mass we perform. So because to get the number of moles of BaCl2, we have to divide the mass by molecular mass. So 416.6 by 208.3, we got 2 gram moles. So once we got 2 gram moles, 2 gram moles multiplied by Avogadro number, we got the final answer. Okay, because 2 gram mole of barium chloride will contain 2 gram mole of barium. So 2 gram mole of barium will contain 2 into 6.022 into 10 power 23, which is 1.2. Is also about Avogadro's number, usage of Avogadro number. A weight of 100 grams each, of nitric acid HNO3 and sulfuric acid H2SO4 is filled with filled in 2 separate bottles. Filled in 2 separate bottles. 2 separate bottles. The weight of 100 grams each of nitric acid and sulfuric acid is filled in 2 separate bottles. Which bottle contains more atoms? And how many more? That is how many number of atoms more. Which bottle contains more atoms by how much? Which bottle contains more atoms and by how much? What is the difference amount? Okay, how many number of atoms more? So if you consider 2 bottles, one bottle filled with 10 grams of sulfuric acid and another mass Ma, number of elements is N. So HNO, number of N is equal to 1, 1, 3 for HNO respectively. Atomic mass are 1, 14 and 16 for hydrogen, nitrogen and oxygen respectively. So now we will do N into Ma, 1 into 1, 1, 1 into 14, 3 into 16, 48. So what you get is 63 gram per gram moles is the molecular weight of nitric acid. So molecular weight of HNO3 is 63 gram per gram mole. So second step is determine the molecular weight of sulfuric acid. Sulfuric acid. So HSO are the elements. So the number of atoms or number of elements are 2, 1, 4. There is 2 hydrogen atom, 1 sulfur atom, 4 oxygen atoms. So then atomic mass, hydrogen 1, oxygen 16, sulfur 32. So multiplying N by Ma, so 2 into 1 2, 1 into 32 32, 16 into 4 64. So summation of this gives us the molecular weight of sulfuric acid. So molecular weight of sulfuric acid is 98 gram per gram mole. Molecular weight of sulfuric acid is 98 grams per gram mole. So now we will make a comparison of two bottles, right? So there are two bottles which both are having sulfuric acid and nitric acid. So if you consider the components in the bottle, so one bottle contains HNO3, another bottle contains H2SO4, nitric acid and sulfuric acid. So both are having same mass. It is given both are 100 grams. Okay, both are 100 grams. So what is the molecular mass? The molecular weight we have determined. So molecular weight of nitric acid is, just now we have calculated, it is 63. Molecular weight of sulfuric acid is 98. Okay. So how to get gram moles? We have to divide them, right? So gram mole is equal to mass by molecular mass. So gram mass by molecular mass. So 100 divided by 63. 100 divided by 63 is 1.58. Please cross check it. Use your calculator and do the calculation. So 100 by 98 is 1.03. 100 by 98 is 1.03. So obviously we have more gram moles of nitric acid, right? So that means nitric acid bottle will contain more number of atoms. That is the answer for first part. HNO3. So bottle with HNO3 will contain how much more we have to tell now. So bottle with HNO3 nitric acid will contain. So what is the difference in mole? First determine, find the how much excess gram moles are there. 1.58 minus 1.03 will give us 0.58 gram moles. 0.55 gram moles. 1.58 minus 1.03 is 0.55 gram moles. So we know that 1 gram mole will contain, 1 gram mole of any substance will contain 6.022 into 10 power 23 atoms, right? So therefore 0.55 will contain, multiplying by 0.55. So 0.55 into 6.022 into 10 power 23 gives us the final answer, which is 3.311 into 10 power 23 atoms more. So this is only the excess amount. It's not the number of atoms of nitric acid. So this much number of atoms are present excess in 100 grams of sulfuric acid. Okay, so I think in the diagram I have made it like 10 gram for just for understanding. But both bottles are containing 100 grams of sulfuric acid and 100 grams of nitric acid. So question was, which bottle contains more atoms and how many number are atoms more? Okay, how many number of atoms more? So we wanted to find only how much excess amount it is, excess number of atom this which bottle is containing. So first we have identified it to be nitric acid bottle containing more number of atoms, because which is having more gram moles, right? So then we find out how much excess gram mole is there. then we multiply it by Avogadro number to get number of atoms, excess atoms that is present in nitric acid bottle. So the next problem is about finding the equivalent weight of one of the covalent agent used in wastewater treatments, that is aluminium sulfate. What is the equivalent weight of aluminium sulfate? Al2SO4 thrice. Al2SO4 thrice. So that is aluminium sulfate. So how to find the equivalent weight? So we know that equivalent weight is equal to molecular weight divided by valency of electrons. So how this Al2SO4 thrice is formed? So 2 moles of aluminium plus 3 moles of sulfate ion, SO4 2 minus 3 number of moles will form Al2SO4 thrice. So what is the number of electrons here?
So how to get equivalent weight of 3.16 gram moles of AMnO4 is 3.16 into gram into 7 equal to 20%. So we are getting this 7. So we have valency of K is minus plus 1, loses electron. Valency of O is 2, gains electron.
How many aluminium atoms are there? First write name of the
Electron gains electron minus 2. Let MnBx KMnO4 1 plus x plus 4 times oxygen minus 2 4 to 7 minus HB is equal to 0. So we use x equal to 7 equal to 0. So x equal to plus 7. So
for oxygen 16 we know. So
number
multiply
of
N into
electron
Me, we
gained
get
or lost
2 into 27 54.
is 31.6 into 7 equal to
1
104.
into 16 192. So making summation we will get the molecular weight. Please always cross check the answer. So I am getting here 342 gram per gram mole. So molecular weight of the coagulating agent used in drinking water Al2SO4 thrice is 342 grams per gram mole. So valency is 6, molecular mass is 342. So we know to find out the equivalent weight. So 342 grams per gram mole divided by 6 gives us the equivalent weight to be 57 grams per gram mole. So equivalent weight is equal to 342 by 6, which is 57 grams per gram mole. So we can write it in sentence. Please write it in the sentence. What is the question? What is the equivalent weight of Al2SO4 thrice? So answer should be, so the equivalent weight of Al2SO4 thrice is, the equivalent weight of Al2SO4 thrice is 57 grams per gram mole. 57 grams per gram mole. That is the required answer. 57 grams per gram mole is the required answer. So we were asked to find the equivalent weight of aluminium sulfate. So we have first found out the molecular weight of aluminium sulfate, SO4 thrice. So we have determined the molecular weight by multiplying the number of elements in the molecule and atomic mass. We got 342 grams per gram mole. So then dividing the molecular weight by valence, we got the equivalent weight of aluminium sulfate. So the equivalent weight of aluminium sulfate is 57 grams per gram mole. So how the equivalent weight is defined for redox agents? Equivalent weight of redox agents. So there may be oxidation, reduction. So that is combinedly called redox reactions. Reduction reaction and oxidation reactions combinedly is called redox reaction. KMnO4, potassium permanganate is an redox agent. So how to determine the equivalent weight of redox agents? The equivalent weight of an oxidizing agent is molecular weight divided by number of electrons gained during the reaction. Number of electrons gained during the reaction. Equivalent weight of a reducing agent is equal to molecular weight divided by number of electrons lost during the reaction. Number of electrons lost during the reaction. So for oxidation agent, we should not forget that molecular weight divided by number of electrons
weight
gained.
will vary
Equivalent weight of
depending upon the
reducing agent
medium,
is
neutral
molecular
medium,
weight
acidic
divided by
medium, and
number of
alkaline
electrons
medium.
lost.
Therefore,
So
whether
we
we
want
should
to
know
know
whether how many electrons are gained or lost.
Okay, so equivalent weight is equal to molecular weight divided by, we can say in general, valency factor. So that is number of electrons gained or lost. So determine the equivalent weight of potassium permanganate in A, neutral medium. Determine the equivalent weight of potassium permanganate in neutral medium, acidic medium, and C, alkaline medium. Alkaline medium. So what we should do first, we should know what is the valency factor in each case, right? So depending upon the valency factor, we have already determined the molecular weight. Okay, so molecular weight divided by valency factor is the equivalent weight in the corresponding medium. So what we will do, so first we will determine the molecular weight of potassium permanganate. We have done this earlier also. So number of elements, atomic mass. For potassium it is 39, so N into Ma. Okay, so for manganese it is 54.93. Okay, 1 into 39 it is 39, 1 into 54.93, 54.93, 4 into 60 it is 64. So adding the 3, what we get is molecular weight of potassium permanganate 157.93 gram per gram mole. Okay, so we can write molecular weight of potassium permanganate KMnO4 is equal to 157.93 grams per gram mole. So first we will go for neutral medium, A case A, neutral medium. So what is happening there? Manganese from oxidation side 7 plus will become 4 plus, manganese 4 plus. So that means the valency factor is 3. The valency factor is 3 for this neutral medium. So what we have written, manganese from 7 plus state it becomes 4 plus state. So the valency factor is 3. So therefore equivalent weight is equal to molecular weight divided by valency factor 3. So we get the answer. Okay. So similarly for the next one is for acidic medium, what is happening? Manganese from 7 plus state will reduce to manganese 2 plus in acidic medium, so it will become Mn2 plus. Therefore the valency factor is, yes, 5. The valency factor is 5. Valency factor is 5. So next do the same for alkaline medium. So in alkaline medium, manganese 7 plus will become manganese 6 plus. Manganese 7 plus will become manganese 6 plus. That means valency factor is unity. Valency factor is 1. We have valency factor 1. So for neutral medium we got valency factor 3. Acidic medium we got valency factor 5. And for alkaline medium we got valency factor as 1. Okay. Now we have to substitute to get what is the equivalent weight. We have seen the formula. Equivalent weight is molecular weight by valency factor. So for neutral medium, it is valency factor is 3. So 157.93 by 6, which is 52.64. Molecular weight by valency factor. What is the molecular factor weight? 157 point. We have determined that 157.93 divided by 3. Next, equivalent weight in acidic medium. Equivalent weight in acidic medium is molecular weight divided by valency factor 5. So 157.93 divided by 5, 157.93 divided by 5 we will get 31.59, which can be written as 31.6. Okay, so we can round it to one digit. 31.6 is the equivalent weight of potassium permanganate in acidic medium. Next, equivalent weight in alkaline medium. So we have determined already what is the valency factor. It is 1. So equivalent weight in alkaline medium is 157.93 molecular weight divided by valency factor 1. So what we get is 157.93 as the equivalent weight of potassium permanganate in alkaline medium. So in neutral medium we got dividing by 3 we got 52.64. In acidic medium dividing by 5 we got 31.6. In alkaline medium dividing by 1 we got 157.93. So in general, so if as a function of molecular weight, equivalent weight in neutral medium is m by 3, equivalent weight in acidic medium is m by 5, and equivalent weight in alkaline medium is m by 1. That is molecular weight by 1. Okay. This will be the last problem for this lecture. Take down. How many equivalents are present? How many equivalents are present in 500 grams of how many equivalents are present in 500 grams of potassium permanganate? 500 grams of KMnO4. KMnO4. So our problem with this kind of questions is it is not mentioned which medium, right? So in those cases we will just write the general answer, or we can assume one of the medium and write for the assumed medium this is the value. Okay. So first what is data is given, 500 grams of KMnO4 is given. 500 grams of KMnO4 is given. So what is the relationship between moles and the equivalent weight? Equivalent weight is equal to moles into number of electrons gained or lost, or valency factor. Okay. First we should convert the given grams into gram moles. To get gram moles we have to use the relationship between molecular weight and gram moles. How it is related? To get gram moles, gram moles is equal to mass by molecular weight. Gram moles is equal to molecular mass divided by molecular mass. Okay. So we have already determined the potassium permanganate molecular weight. So we can do it again, no issues. Molecular weight of KMnO4 is, for potassium it is 39, for manganese it is 54.93, for oxygen it is 16. For potassium 39, manganese 54.93, and oxygen 16. Okay, when it is oxygen molecule O2 we have to write 32. Here it is this. So what is the molecular weight? 39 plus 54.93 plus 4 times 16 we get 157.93 gram per gram mole. 157.93 gram per. See, in detail we have done it in previous problems. That's why I have done it directly. Okay. So now, so once we know the molecular weight and mass is given, mass by molecular mass will give us how many gram moles we have. Okay. So molecular weight of KMnO4 is 157.93. So mass is given 500 grams. So mass by molecular weight, do it in your calculator. Gram moles is equal to 500 grams divided by 157.93 gram moles. Gram per gram moles. So gram get cancelled. So we get so much of gram moles. What is the value? Please do it in your calculator. 500 by 157.93. What is the answer? 3.16 gram moles. Okay. So now the question is, we know the relationship equivalent weight is mole into number of electrons gained or lost, that is valency factor. So now we have to consider a case, we will assume acidic medium. Okay, when it is not given, we are assuming acidic medium. If you ask why not other medium, yeah, you are welcome to do it. Okay, so here I am just assuming it to be acidic medium. So 3.16 gram moles is the given moles. We have 500 gram is equivalent to 3.16 gram moles, and multiplied by the valency factor 5. That is, we have assumed it to be acidic medium. So you have to assume, if you are assuming neutral medium, you have to multiply by 3. If you are assuming alkaline medium, you have to multiply by 1. Okay, so that way here for assuming acidic medium, so what we get is 3.16 into 5, 6 5s are 30, 1 5s are 5 plus 3 8, so we get 15.8 as the answer. So we get 15.8 as the answer. What is that? This is the equivalence that is present in 500 grams of potassium permanganate. That was the question asked. So what we have done in this problem, since it is more general, we have assumed it to be acidic medium. Okay, so mass is given as 500 grams, which we have written. That is the given data. So we have written what is mass is given. So we have written the formula, equivalent weight is equal to number of moles into valency factor. To get given moles, we have first determine the molecular weight 157.93, and mass divided by molecular weight, we got number of moles, that is 3.16. and to get equivalent weight, we have multiplied the gram moles into valency factor 5, assuming it to be acidic medium, and arrived at the solution 15.8. Okay, this is one of the repeated questions in competitive exams. Okay, so molecular weight of KMnO4 as a function of equivalent weight in different medium. So the question is, the molecular weight of potassium permanganate in acidic medium and nutrient medium will be. Molecular weight of potassium permanganate in acidic medium and neutral medium will be. There are 4 multiple choice options are given. We have to choose the best. A, 7 times EW equivalent weight and 2 times equivalent weight. Second choice, 5 times equivalent weight and 3 times equivalent weight. Third choice, 4 times equivalent weight and 5 times equivalent weight. Next choice, 2 times equivalent weight and 4 times equivalent weight. Yeah, just now we have revised all the topics, so we are easy to give the answer. But if you want to cross check it, so which is you have to choose the best answer. So what we will know is, we should recall what is the relationship between molecular weight and equivalent weight. Okay, so for neutral medium, what is the relationship? For acidic medium, what is the relationship? And for alkaline medium, what is the relationship? We have to get. Okay, so that what is given, we can easily find out the answer. So first recall what we know. So we know that molecular weight divided by 3 is the equivalent weight in neutral medium. Molecular weight divided by 5 is equal to equivalent weight in acidic medium, and molecular weight divided by 1 equal to equivalent weight in alkaline medium. So here the question is about acidic medium and neutral medium. Acidic medium and neutral medium. So second and first is asked. So m by 5 and m by 3 are the answer, or you can say m equal to 5 times EW in acidic medium, m equal to 3 times equivalent weight in neutral medium. 3 into equivalent weight in neutral medium. So our correct answer for the given question will be 5 into EW and 3 times EW. Which option is having that? B option. 5 times EW and 3 times EW. So option B is the correct answer. So we have to write 5 times EW and 3 times EW is the correct answer. That means option B is our correct answer. 5 times EW and 3 times EW is the correct answer. That means which option is correct? Option B is correct. Computer G, please lock option B. Friends, in this lecture we have seen numericals on determining the atomic mass, molecular weight, how to convert from moles to mass and mass to mole. The next topic that we are going to discuss in our classroom is, yes, we are going to discuss about composition of solutions. We have seen gaseous solutions. How to express the composition of solutions in percentage, mass percentage, concentration is expressed in different units. And before that, we will be determining the average molecular weight of these solutions. For example, average molecular weight of air, various compositions we have to determine. So once the average molecular weight is determined, then we will determine the density. Density of various gas mixtures will be determined. So then we will move on to mass fraction, mole fraction conversions. Thank you so much for watching this lecture. If you have any doubts, please comment.